All right, so yesterday we covered a bunch of SQL stuff, and then today we are going to do a little bit of review, and then we're going to move into something called active record. So schema design is a big part of your job as a software engineer. Your job essentially is to create something from nothing, and something from nothing is always going to start with a database. Because as I've mentioned in the past, the web is just one giant form. Go to any page, it's a giant form. Go to walmart.com, you have to log in, it's a form. You want to sign up, it's a form. You want to buy something, it's a form. You want to add a credit card, it's a form. Like everything on the web is a giant form. And that data, once you submit it, has to go somewhere. So again, when it comes to SQL and to databases, like this is probably the most important thing that you can do. Obviously, there's code to be written, but in the end, it's all about the data inside your database. So there's a challenge from yesterday called Schema Design, and this is a very legitimate whiteboarding question. They're basically saying, like how well can you design your databases? How well can you talk through things? There's two different tools that I felt were useful. One was called, oh, this one's dead. Oh no. Okay, I know it's somewhere else. Hold on. Nope, it's dead there. I'll find it.
I think Aaron found it by Googling.
What's that?
Aaron found it last night just by Googling it.
Yeah, it was like a scatter plot.
Oh, here we go. There's some right here. I'll update this in a second. So this gigantic scatter plot, or like graph paper or whatever, I remember I heard some people just go like, what is this? What is that? And this is essentially, it's not a place that you write your database. It's just a place where you design your database. So we'll use this morning. You can also use Quick Database Diagrammer. This is also fine. I'm more of like I draw boxes type of person and connect them with arrows. And the other one's a little prettier. So let's take a look. A few things to keep in mind as we design our schemas. All the tables are plurals. All the identifiers should be lowercase. Everyone should have an ID. Foreign keys should have a have an ID suffix. Let's try just pick one. It doesn't matter to me. Grubhub. We have orders, restaurant, menu items, and users. Let's try it. So I'm going to add a table and just place it anywhere. I'm going to call this orders. And again, like this is in no part. You can move this around if you'd like. It's not a big deal. Again, this is just a visual representation of things. So we have what else is there? There's a restaurant. Remember, these are the names of my tables, and because there's many entries, all of these table names are going to be plural. I believe there's another one called menu items and users. And there's no particular method to my madness. I'm just like putting it anywhere. I'm just going to throw things around. Now let's talk about some of the things that an order might have. So I have this table now. I'm going to add a field to it. And maybe this will be just a text box for now. What does every single order have?
Price.
A price? The total price, perhaps? I like it. We have a total price. What else does every order have?
Description of what you ordered.
Sure, like some sort of description. This would probably be a text field. It doesn't matter. Like you can choose whatever you'd like here. This is just for visualization purposes. This is not actually going inside your database. So description, that's fine for now. A menu item. So let's just go to restaurant. What does every restaurant have? The menu. What else?
Items like food that they sell.
Cool. So I know I have to associate menu items and restaurants in some way. That's in the future. But I'm just like statically, like without doing any join tables or connecting foreign keys or anything like that. What does a restaurant have? Name and address. Let's just keep it simple. So I like that. I'm going to add another one called address, and maybe one last one for type of cuisine. All right, a user. I don't know. We'll just do name, email address. And then a menu item. So a menu item is a item that's on a menu. What does every single menu item have? Price, some sort. We'll keep that as an image.
Description or name.
Yeah, we'll have a description and price, description, and name. All right, so at the very core of it, obviously there's much more than these things for all of these different tables. We're just creating something basic. We're trying to associate these together. And I was talking with some people yesterday when they got to this challenge. The thing that you have to think of is what has many of the other and what belongs to another thing. So I'm going to start with orders and just kind of go down the line of all of these things. So we'll just start with has many. Does an order have many menu items? And does it, and to do the converse of that, does a menu item belong to an order? How does that sound to you? An order has many menu items, and a menu item belongs to an order.
Yeah, first
Yeah.
things.
An order has many menu items because when on one particular order, I can order, you know, a hamburger, a cheeseburger, and some fries. Those are three things, so three menu items that are on my order. So this has many of this, and a menu item belongs to an order. Okay, so when one thing belongs to an order, when one thing, this menu items, belongs to another, you're going to have to create a foreign key. So I'm going to have I'm going to add a field. It's going to be called order ID. I'm going to basically connect this to here. So as of right now, every single menu item belongs to an order. Again, an order has many menu items, and a menu item belongs to an order. So this one particular item belongs to this order.
So you always put the ID on the menu part.
I always do. So if one thing belongs to the other, the thing that belongs to it has the ID on there, the foreign key on there. Now let's think about this. Does an order have many restaurants? And conversely, does a restaurant belong to an order?
Not necessarily,
Not necessarily. Okay.
because I mean, you can order from different restaurants. Order, you know, an order can order from one restaurant, but not order from another restaurant. The order can have.
Does an order have many restaurants?
Say the opposite.
That's what I mean. Like an order cannot have many restaurants.
An order can't have many restaurants. An order just belongs to one restaurant.
Right.
Okay. So does an order have many restaurants? No, because one order comes from one restaurant as of right now. I'm sure in the future Grubhub will expand to do like multiple restaurants. Like I want a cheeseburger from McDonald's and I want fries from Burger King because the fries at Burger King are better, but the cheeseburger at McDonald's is better. That would be a total nightmare for Grubhub. But
you think they'll do that eventually?
maybe, who knows? It's probably not. It's probably not. There's a reason why they haven't done that yet, right? So an order probably doesn't have many restaurants, but an order probably belongs to a restaurant, right? Like one order belongs to one particular restaurant. What are your thoughts on that?
Sounds good.
Sounds good. All right. So if an order belongs to a restaurant, where does the ID go? Where does the foreign key go? On the orders or on the restaurants?
Orders.
On orders. Restaurant ID. And then I'm going to connect this to here. I hear you. What's up?
I was thinking that there's no reason to connect orders and restaurant.
Mm-hmm.
It's just the restaurant menu and then the orders to menu.
Yeah, that's a legitimate point. So as of right now, Leanna said there's no real reason to associate an order with a restaurant because you can associate a menu item with a restaurant. And I was like, that's fair. As of right now, let's just create as many associations as we can just to get in that practice, and we can see what we can cut out. All right, so we took care of orders. So a user, does a user have many orders, or does an order have many users?
Usually have many orders.
A user has many orders, and with that, does an order belong to a user?
Sure.
Cool. So where does the user ID? Where does the foreign key go?
On orders.
On orders, yeah. Great at not giving things away, huh? Okay. Does a user have many menu items, or does a menu items have many users? Are these going to be related in any way?
Sure.
Yeah, menu items can belong to users, I think. Like, because if you wanted to query it and say, like, what does Danny order the most of? Or like, in January, Danny ordered 37 egg rolls.
Sure. I'm going to say no.
Okay.
So Sri's reasoning was like, let's say that I wanted to get from users over here to menu items. Like, I want to see what like Danny ordered in the last month in terms of all the menu items. One thing I wanted to point out to you is that you can kind of follow the lines. So a user can get to orders and an order can get to menu items. So you don't need actually a direct correlation between menu items and users. You can get from one point to the other through this table in the middle. As long as the lines are connecting, you should be able to connect. You should be able to get all the way there. That being said, a user doesn't really have menu items because that's what a restaurant's responsible for. So I'm probably not going to go with that. Does a user have many restaurants, or does a restaurant have many users?
Restaurant has many users.
Again, a restaurant has many users, but we don't need to create a direct link here because we can go through orders and get to that point.
I see that.
I think I'm a little trigger happy with making connections. I think
Again, you have to.
You're still Marine, buddy.
All right, let's talk about restaurants now. Let's go in this counterclockwise circle. Does a restaurant have many users? Nah, kind of, not really. Does a restaurant have many orders? We said that already. An order belongs to a restaurant. Now let's talk about the relationship between menu items and restaurants. That's the only one we haven't had so far. Does a restaurant have many menu items, or does a menu item have many restaurants?
Restaurant have many menu items.
Sure. So a restaurant has many menu items. Makes sense. You walk up to, like, my favorite restaurants in the world are diners, just like diners at 11 o'clock at night, because you can open the menu, have 700 things on the menu. So that particular restaurant has 700 menu items. So if we know that a menu item belongs to a restaurant, where is the foreign key going to be?
Menu items.
Oops. So this is more or less like a decent starting point for us. Now we're going to start refactoring things. We're going to talk about a join table, which we haven't talked about yet. Let's review what we have. So a user has many orders, and an order belongs to a user. Totally makes sense. No issues with this green line here. A restaurant has many orders, and an order belongs to a restaurant. I don't see any issues there. This line is perfectly correct. An order has many menu items, and a menu item belongs to an order. I'm seeing some issues right over here. And before I reveal what the issue is, does anyone know what the problem is between these two?
Well,
The restaurant IDs?
No, between.
The menu item can be on multiple orders.
Can you explain that a little bit more?
So when you're looking to create your schema, sometimes it's about how is the simplest way to display the data. And if you have a field of like order IDs, order ID would be this long list of all of these orders, because every time somebody ordered it, you would have to put it on. You would have to add another order ID in that column. Simpler way order would house the menu ID, so that yeah, you might have 2 or 3 items, but you wouldn't have, the bizarre of every time there's a new order, you have to add another order ID. But that's how I think of it.
Yeah, that's a pretty good explanation. So the issue what's happening here is every single menu item only belongs to one order at this particular point. But think about that for a second. You go to McDonald's, there's a menu item called cheeseburger, and only belongs to one order. How many cheeseburgers do they sell per day? And if you just associate one menu item belongs to one singular order, You have to create new cheeseburgers every single time. An order can have many menu items. So an order has many menu items, and a menu item also has many orders that it can belong to. This is called a many-to-many relationship. Like this one is pretty simple. Like an order belongs to a restaurant, and a restaurant has many orders. This is just a has many and belongs to a relationship. But this is a many-to-many relationship. An order has many menu items because on your order you can order 5 or 6 different things. And a menu item has many orders because that one cheeseburger can be sold to 300 people today. What you need here is something that joins them in the middle, and that's called what's called a join table. So I'm going to add it real quick. Oh crap, what did I just do? Stop. No, delete. Remove. Field. I'm going to add a table in the middle called orders menu items. This is what's called a join table. It joins two tables together, and that's all it does. And let me just show you what it looks like. Order ID, and then menu item. How do I remove the foreign key? So again, all this does is join 2 tables together because there's a many-to-many relationship. Before, when I had this order ID, like one particular menu item only belonged to one order. So I'd have to repeat every single time I want a new cheeseburger, because then it's like, I want to reuse the cheeseburger, but it's already associated with order number 1. All right, quickly, let's put another cheeseburger inside the database and associate with number 2. The third person comes up to your window. I'd also like a cheeseburger. Oh crap, my cheeseburger is now associated with number 2. Let's create another cheeseburger and associate with number 3. It's not reusable, right? That's the idea behind it. Like it's just not reusable code. So what happens is when you have an order has many menu items and a menu item has many orders, many to many, you have a join table in the middle. This basically just joins these 2 tables together, and that's pretty much all it does.
Can we now move our relationship between the orders and restaurants to the join table? Or is that not?
So you have to. So probably not. I'd say probably not. And the reason I'm saying that is an order belongs to one restaurant. Like one order to one restaurant. Like there's never a time, as of right now, there's no company that says when you create an order, you could have many restaurants inside your order. Like when you order something, you go from one restaurant. Like you order pizza online, it's gonna be from Papa John's or Domino's or Pizza Hut. Like it's not going to be from all 3. As of right now, an order only has one restaurant. If it was like one order has many restaurants and a restaurant has many orders, because you've heard that menu to many relationship, you probably need a join table in the middle. As of right now, you do not.
So does that join table give you the ability to put multiple menu items on one order?
It does. So an order has many menu items through this table in the middle. So you would say an order has many order menu items, and then from there you can say an order has many menu items. So as long as you create this association here, then it can automatically connect from here to here.
Can you give like a concrete example?
I will do that. I'll do that today.
Okay.
When we get to active record.
Okay.
So this is just kind of like conceptually. Other than that, I feel pretty good about this one. Order has many menu items. A menu item has many orders, so you need a join table. A menu item belongs to a restaurant, only one restaurant. Restaurant has many orders. Order belongs to a restaurant. User has many orders, and then from here you can get from users to menu items to restaurants. Like you can just kind of chain these all together. You can get from here to here, or you can go from here to here to here to here. Like as long as there's a line that connects them, you can get there. How do people feel about this?
I feel good. I don't see the use of the order menu item.
Mm-hmm.
Like it's still gonna do the same thing, but I think I'll get it later.
Sure.
Maybe.
The idea is I'm gonna have like 40 records. If I didn't have this right here, let's just pull this all the way down here, so it doesn't exist anymore. If I were just to have orders and menu items, a menu item belongs to an order. That one we determined right at the beginning. I would have to create new cheeseburgers records every single time I sell a cheeseburger.
So you kind of want that. Like if you're the business, you need to know how many cheeseburgers to sell.
Yes.
Or buy.
That is accurate. Like,
I think that would be a separate field quantity.
yeah, that would be, yeah. So it's kind of like, I can why would I enter exactly the same data with only one number changing like over and over again? Like this has more stuff in it. It has price, description, name, restaurant ID. This would get longer. This has two things in there. They're just numbers. So it's like one is smaller to save than the other thing.
Got it. Okay, that makes sense.
So if the menu items had a quantity field and say you ordered 5 cheeseburgers,
Mm-hmm.
one order ID would equivalent to or would match the menu ID, which would have 5 in it.
You can also just add, for that one, the question was like, how do I add, like, where would I put quantity if I ordered 4 cheeseburgers? I'd probably just add one called quantity. Because then it's like an order has many menu items. Like it's kind of like for this particular order number 1, I'm ordering from the menu item number 3, which is a cheeseburger, and I'm going to order 4 of those. And that's how I would calculate it here.
I was going to say, in terms of data flow or information, so the user only sees the orders.
Correct.
The orders basically is joined with the menu item, so it contains both the menu items and it also it looks like the restaurant can see the orders.
Mm-hmm.
The orders doesn't care about necessarily the restaurant. It just knows that it needs menu items and it's coming from a restaurant.
Well, it definitely need to know about the restaurant because like only certain restaurants carry certain. I'm not gonna go to Papa John's and order like falafel, right? That's not something that they're gonna sell. I hope not. At least I don't think you'd want to order from.
So the rest, but as of right now, the restaurant does know what menu items it contains. And
Correct.
It also knows what its orders are.
Yes.
So that's why I'm a little confused as to why we can't just join the join table to the restaurant so that it knows both things at once. But I suppose that's not how it works. So
You can throw. Meh. I suppose you
it-
could.
you know,
I suppose
like,
you
it
could
doesn't
put it
work
on
that way.
here.
It doesn't work that way.
So you could put restaurant ID on here. I just don't. I personally don't see the real benefit in that because I think it's just kind of like you would have to repeat the restaurant ID and over and over again when it's
Yes, I won't understand that until I actually have to query it.
Yeah.
And see it in action. So.
Right. So this is like an idea of like how I would probably go about creating this Grubhub thing, and I'm gonna update the schema design pretty soon. All right, and then nobody got to SQL queries, so let's jump down here. There are a lot of these, so I do want you to finish these by the end of the day. I do have all the answers in case that you actually do need them. So let's just take a look. I'm gonna clone this down. Take a look at the README that we have. In this challenge, we'll be writing a number of different SQL queries against our school database. Once we have a working query, we're going to check our work against the solution provided. Make sure that you have everything. All right. So it says create a new file with the SQL statements you've written to get the desired results. So I'll just do answers.sql. And I'm just going to grab all of this. Dump it in here. Make sure everything is commented out. I don't have the schools database. Does anyone have that so I can use it?
Yeah, it's not basics.
Basics. Okay. Whose solution should I use? I'm choosing the first one. Aaron, I'm using yours.
Actually, did we do that right? Yeah, I think we
Find out.
We have the raw data.
It won't work. And John, I know why it won't work. Our IDs, our foreign keys were all built as varchar as opposed to building them as integers, and so we were having a type error when it came to our join tables, our inner join.
Yeah, remember your foreign keys are always going to be IDs because they're just numbers that look into other places. All right, so let's jump to another
So
one.
they were IDs, but their type was wrong.
Okay. So Danny's uses varchar.
Yeah, I think his ID is foreign.
What about yours?
I think ours is integers.
Okay, we'll grab yours then. Let's see. I'm gonna grab this here.
I hope not.
All right. Hopefully this is not embarrassing. So we'll find out. I'm gonna save this as schema.sql, and we can just kind of see what we've got. So if the student table exists, drop it. I'm gonna create students ID, first name, last name, address ID, integer. This points over to here, line 1, line 2, that's fine. Classes has an ID, name, and credits. Enrollments. This is a join table between students and class and grade. Where's class? Okay, student. Okay, that's fine. Do we have any seed data for this?
Yes.
I know they all kind of built on each other yesterday. Let's jump over to SQL Basics. Seed data.
Don't see that yet, but then.
Okay, so if this all works, let's find out. So again, like you can type this all line by line inside of your SQL, your Postgres thing. So if I go to like pSQL, oh no. So we did all the installation on day one, like when no one understood everything. We already installed this, so it should be working for you. I'm gonna go to pSQL. Let me just do create DB. You can just as easily go in here and just copy line by line. But the issue with that, personally speaking, is like if you mess up one, if you forget a parentheses, if you forget a semicolon, everything blows up. You got to go back and type it all again. I like to keep track of it in here so I can just copy and paste. If all goes well, I should be able to run schema.sql and then seed it without any sort of issues. Let's find out if I can do that. So here. All right, so here's schema.sql. So if I run SQL schema.sql, pSQL, how do I run this?
You had to do the last answer.
Okay, so pSQL this.
Or the database name
PS,
first.
yeah, PSQL.
And it's just one.
J,
Just one.
Just
Yeah,
one?
just
Just
And
one
the
chunk.
database name after pSQL.
Okay, what do you want to call it?
You
Your
already did it.
database name.
Oh, I can create whatever I want.
Oh, school.
School. School does not exist, so let me create a database called school. And then shove that in. All right, so let's kind of read through what we've got here. So I've created a database. It's empty, called school. And I'm telling pSQL to, inside of school, run all of this stuff inside of schema.sql. So please note that table students does not exist skipping. So they dropped the table, they created the table. There's no big blowups, even though it looks kind of scary. There's output, but it didn't blow up. So if all goes well now, I can also run the seeds.sql. All right, it worked. I see a bunch of insert statements. I go to the bottom. It looks like nothing blew up. Let's verify that we get what we want. So I'm going to do pSQL for school. Sorry. This is using the Postgres client called pSQL to load up the database called school. Should I make this bigger? You guys good? So I'm inside of school now. And if I do, there's different commands for different things. If I want to quit, it's \Q. If I want to look at all the tables, it's \D. So there are a bunch of things. I have addresses, classes, enrollments, and students. This ID sequence thing is something that pSQL needs in order to query your database and keep everything running in succession. So let's jump over to \D addresses and see what we have. Okay, so we have line 1, city, state, and zip code. I want to select everything from addresses. See what we get. So we have 4 records, and this all looks good. Let's select star, select everything from students. Have all of these particular people. I want to see some addresses as well. Everything looks good.
And we were getting an error message when you type something wrong the first time.
Yeah.
And then you type it right the second time.
Oh, it's,
What is it?
you would type it right. You type it right, and then the first time it always gives you an error, and then the second time it'll do it.
Is it the drop if exists?
No, just the SQL queries.
Yeah, it's just like a command in here that it always, like you gotta do it twice. The
I
first
always
time-
have to do it twice. I'm not sure which command you're talking about.
Any command we do.
Any command you do, you have to do it twice?
Any
Were
query.
you remembering your semicolon? Because that was what we were bumping into.
Oh, if you don't have a semicolon,
Yeah, and then we try it again.
so you do it,
The semicolon. Yeah, we get that.
you get that.
Yeah, exactly.
That's because it's doing it twice.
It's doing it twice. You have to add the semicolon at the end
Yeah,
in
so
order
you
for it to run.
So if we don't do this, if we don't do the semicolon, just do another semicolon.
Yeah. So
And then
so let's say the answer of why things are happening like that is SQL is very strongly typed. Like if you're missing the semicolon, it's not running because it doesn't know that it's over. Because I can write
Oh,
again. I can do like select from addresses where state is equal to Maryland. I can this can become a multi-line query, but the moment I type the semicolon, then it runs.
how do you end the run without quitting out of the database?
How do
You just press semicolon enter.
Yeah,
to enter.
That's it. That's what I just did here. Because it's like I wrote the first line, I pressed enter, nothing happened. Entered the second line, nothing happened. I just pressed a semicolon and then enter, and then it came out.
Okay.
Yep. So let's write some of these queries over here. So all the rows from the classes table. What is it? What is it going to look like?
Select asterisk from classes.
Sorry, one more time.
Select asterisk from classes.
Select asterisk from classes.
Select.
Select. Okay. All right. So let's do select star from classes. So my general thing is for all the SQL commands, make sure that they're capitalized. It will still run lowercase, but it's just like at this point, like you're absolutely talking about SQL, and you can kind of see like the highlighting is going to come up this way as well. So select star from classes. Let's see what we get. All right, semicolon. Looks good. Let's do as many as we can before 10:30. Select the name and credits from the classes where the number of credits is greater than 3. Someone else.
Capital select name, comma, credits.
Mm-hmm.
Capital from
Mm-hmm.
classes.
Okay.
What capital where?
Mm-hmm.
And then in one quote, we're gonna type credits
Mm-hmm.
greater than 3.
Let's see if this works. Add the semicolon at the end, and we'll run it. All right, where credits is greater than 3. I think the only thing that you're missing is actually, I think it's just this. It's not a string. There you go.
Right on.
All right, there we go. All right, next one, Danny, you're up.
select asterisk from classes where credits percentage sign to 0. It's 1 equals. The name for it.
Looks good. Again, there's that percentage sign. Again, we're in a totally different language now. Like Ruby uses it, JavaScript uses it, SQL uses modulo. So you can kind of see like those concepts that we learned in weeks 1 and 2 are going to start carrying over. Raymond, let's go for this one. All of Tiana's enrollments that she hasn't yet received a grade for. Sorry, this is much harder.
Well, select asterisk from enrollments where
Here's
I already did this before. I know that Tiana is student ID 1, so we're in the students table. So where's
She is ID 1, but let's not use that.
oh, that's what I used.
Nope.
Well, because I did a /D and I checked.
I know.
I noticed that enrollments had student IDs.
Yep.
So I did a /D on students.
What happens when there are 10 million records?
Oh yeah. Well, because the on line 22, that one's asking to select by her first name and not her student ID. So I just figured the one before that is the student ID. That's how you access it. But that's how, I don't know how else to do it.
Okay. Anyone else?
where single quote.
You need inner join.
You need an inner join. What is an inner join?
It's like a join table almost.
Yep. So there's different types of joins. The most common one is called an inner join. The visualization looks a little something like this right in the middle. So there are different types of joins. Some of them are very popular and some of them are not as popular. The inner join is this one right in the middle. So it's basically saying, give me the common things between where, give me all the tables that match up with this common, middle section. You need to join enrollments and students together. So if I jump over here and I look up /D of enrollments, you can see that a enrollment has a student ID. So you can inner join an enrollment and a student and the students table together. So tell me what to type. Select star from enrollments. I know I'm going to need an inner join. I can actually just do join. Join is synonymous with inner join.
So I would do join or from enrollments, join students. And on the student or enrollments dot student ID equals students dot ID, where the grade 4, where grade in lowercase.
You need Tiana.
Where first underscore name equals in string Tiana, and grade capital is space capital null.
I'm going to be very surprised if this works. We're just going for it. Let's see it. Okay. Oh, there it is. Not bad. So we got select everything from enrollments where, let's see, what was it? All of Tiana's enrollments that she hasn't yet received a grade for. Okay, let's do that, and let's get rid of just first name is Tiana, just make sure that we get two different things. Looks like, yeah, number 3 is the only one that she hasn't received a grade. So let's dissect this a little bit because we got really advanced real fast. So select star from enrollments. Everyone knows that. Select everything from the enrollments table. But the enrollments table, when I take a look at it, does not have students on there. So there's no easy way for me to get straight from students does not live on enrollments, but I can see that I could connect to the students table using the student ID. So select everything from enrollments. I'm going to join the enrollments table, that first circle, this first half of the Venn diagram, table number A. I'm going to join it up with table number B, which is this B table right here. What are you going to join it on? How are you joining these two things together? You can't just say I'm going to connect them somehow and magically. I'm going to connect them specifically on the enrollments table. There's something called student ID. And on the students table, there's something called ID. So I'm going to connect it where on the enrollments.studentID equals students.ID, meaning that the enrollments have a student ID field that's going to match up with the students, which has an ID field. If those two are the same, we can join them together. That's like that middle section, this filled in red portion. And then from there, I'm doing some a couple of things. Like right now, like if I got rid of this, I'm just joining every single student to their enrollment. But I only care about Tiana. So I'm looking for the first name is equal to Tiana, and that I can type in first name like this because there's only one field called first name and it exists on students. And the grade is null, like there's nothing inside of there.
Can you say that student's ID equals student's ID part again? Can you explain that one more time?
Sure. So again, we have two. If you take a look at enrollments, there is, like inside of enrollments, everyone can see there's no student, right? There's no information about the student whatsoever. But there's a student ID, which means that I can connect one table to another. So select everything from enrollments. Enrollments is this A circle. And I'm going to join it to students, which is the B circle. The thing I'm going to join it, like how are you associating these two together, is basically saying on the enrollments table, there's something called student ID. And then on students, there's something called ID. Where these two are identical, this equal sign in the middle, where the enrollments.student ID, which is this thing, and the students.id, where these two things match up, like the numbers match up identically, that's the cross section that I'm talking about. And then once I cross those together, I'm going to look for the one where the first name is going to be Tiana and the grade is going to be equal nothing. Let's do one more. And then,
John?
yep.
Can you take out that last line and see what we get?
This last line?
Where that starts with where?
Sure. Now I have everyone. So this, when I do a select star from and I join, I basically create an output table that basically contains everything.
So everything with both tables?
Everything from both tables together,
Okay.
which is totally okay right now. We don't have that many rows. We only have 16 rows. But it's kind of like if you were to join like a user has many orders. If you did all user orders, like for Amazon, you're looking in the trillions. You know, so it's like I'm only looking for the user orders for, you know, for this particular email address, and that's how you can query all of your Amazon orders all at one time.
And then is it a better naming convention, or does it matter? Like instead of ID, like if it's a student's table, the first thing you do is student's ID. If it's enrollments table, you don't name it ID, you name it enrollments ID.
No, because the idea behind it is like student, you can always rely on ID being the primary key of whatever table you're talking about. And then this is the foreign key. So every single, like, you're not going to do enrollments.enrollment ID. It's just going to be enrollments.id.
Okay.
And then we'll take a break. All of Tiana's enrollments that she hasn't yet received a grade for, selected by her first name, not her student.id. So this, I think they kind of knew that you were going to look because it was so short. So let's get somebody else. It's going to be pretty similar to this one up here. Aaron, let's go with you. How would I type the SQL statement for this?
Okay, you're gonna go.
Actually, I think this is the same thing. I'm sorry.
Yeah, that's why I grabbed it by student ID on the first
Yeah,
one.
this is identical to this one. So we're going to make one small change right here. So it's all of Tiana's enrollments that she hasn't yet received a grade for, selected by her first name, not her student ID, with the class name included in the results set. So I will get you started. It is everything here.
You're gonna select not the wild card.
Okay.
You're looking for enrollments. So you're gonna say you're also looking for the class name.
Mm-hmm.
So you want to put the I believe it's class.
Okay. Take a
Let
look.
me look at that.
There's also a class ID here.
Okay. So it's class. Wait, can you go back to that enrollments really?
Sure.
All right. So you want to select the grade and class ID.
let's read this again. So just so we're clear, I want all of Tiana's enrollments that she hasn't received a grade for, selected by her first name, which we've done, not her student ID, with the class name included in the results set. So I know that I need well, actually, what are the two things that I need?
You got, it says class name.
Mm-hmm. So I think that's one of the things. I need the class name.
Yeah.
What else do I need?
You're gonna need the grade.
I don't need the grade.
The grade for has not received. Oh, Tiana's not received for selected. The enrollment.
Yep. So I need all of the enrollment. So there's two things I need. I need enrollments and I need the class name. Now I'll give you a hint with the enrollments. So select everything from enrollments. But I also need the class name. So how do I add on a class name on here?
You're gonna have to. You have to do a dots. Class. ID.
Now let's take a look at what \D for classes looks like. So class has a name, so it's not the ID. I can do something with the classes.
Okay, so you want to do classes.name.
Yeah, we could try. We can do that. I think it's select star class.name. Let's find out. I don't know.
I think it's gonna be classes.
Classes.name.
I think with this one you have to do another inner join.
You do need another inner join.
So you're gonna have to join. You're gonna have to join basically. I believe enrollments.
Mm-hmm. To what?
You're gonna have to join that on classes.
Good. So join classes on. It's the same thing as this one. It's enrollments.class_ID equals classes.id. This is what we get. Hold on. \x will make things not appear like on it. And it looks a little something like this. It looks a little nicer than reading it like this, right? So let's see. Select star, select everything from the enrollments. And yeah, I think that'll just about do it. But I'm showing that this is showing up twice. I think it's because I'm selecting everything. How do I just get the enrollments?
You want to type enrollments.
Maybe.
That's what you wanted.
I don't know. I don't think so.
Okay. What is it asking?
Again, I just want the enrollments that she hasn't received a grade for, so it should look a little something like this, with just an additional thing that says name, like class name or something like that.
So you're gonna select. Should just say. Wait, say that one more time.
So like this is the output that I expect, but I also want an additional line called name with Spanish 210.
So you might want to do enrollments dot. I think you're gonna do it down on line 28.
I'm sorry.
So it's going to be enrollments.class.
I think we're going the wrong direction.
Yeah. I really, okay, so yeah, okay.
Let's see if this works. I'm not sure if it does. The answer here. I just want to see. Nope, they don't like it. Here it is. So again, let's take a look. So it's enrollments, everything from enrollments. But if I just did star, it says select everything from every single table together. That's not what I want. I just want everything relating to enrollments and the class name. From the enrollments, I'm going to join it to the students. I'm going to join it to the classes, where the first name is going to be Tiana and the name is going to be Null. I feel like I lost everyone on this particular join.
It's a hard one.
This one is a hard one. Okay, so let's just take a look. Let's read this carefully. So we're looking for everything related to Tiana's enrollments, like all of the stuff. Like we did this right here, all of Tiana's enrollments that she hasn't yet received a grade for. I'm just going to bring this down. Selected by her first name, which we did, not her student ID. We've already done that. We've done all the heavy lifting here. With the class name included in the result set. So again, I'm looking for two things, the enrollments and the class name. So it's just, I know I need everything from enrollments. So that's where this dot star is. And classes dot name is the class name. Look at enrollments. I joined enrollments to student ID, right? So I was able to connect from students, from enrollments to students, and get all of her information. I can also do the same thing from enrollments and jump into classes. So all I really did here was I just copied it over again. So I know I have to enrollments. I have to join into students. And this inside of enrollments, as you can see, there's something called student ID that's going to match up with an ID on the students column. Similarly, there's a class ID on enrollments that will match up with a class.id. That's this line 32 right here. And then the same thing where first name is Tiana and the grade is not is defined, or where the grade is not defined.
When we do a query like this and we join stuff, that only exists for that query. Like we're not creating a new.
You're not creating a new, like an entirely new table. The result is the table that comes out is a result of you running this. There are certain ones that like your business people may like say like I want to see all of the past orders of the past 30. Like you might have to create like they're called Postgres views. It's basically like I'm going to create an alias table, which is going to be just this every single time, and then so they can check at the beginning of the day how many new customers, how many new purchases do we have from this particular region in the world, so they don't have to write this over and over. They create like a separate table for it that will just run this every time.
So the join table you made in the scheme is totally different, or is it a query, or is that like a physical thing you create in your database? So
the question was like this join table that we did a little bit earlier, what happens to it? This is an entirely new table. And we haven't gotten there yet. I'm just saying like we're getting ready to do that today.
It has nothing to do with it.
Has nothing to do with the inner joins.
Okay.
Yeah. This is basically the relationship between a user and an order. Okay. And then a user to an order to a restaurant or something like that. All right, let's take a 10-minute break. We'll be back at 10:50 and we'll cover some new stuff. Again, SQL, don't worry. It's like it's just rote memorization. Just keep doing it. Just keep doing it. It'll only work one way. So just keep doing it, and you'll get better. So don't get fearful if you're not there right now. So we'll be back in 10 minutes, 10:50.